This is Physical Science 1, Chapter 3, Part 3 on motion, acceleration, and forces. In this portion of the video lecture, we will be discussing force. We've discussed that motion is an object's change in position. So what causes that change? Well, forces cause the motion of an object to change. So a force is a push or a pull on an object, causing it to move. So what is force? We can take a look at different ways that forces are applied. Net forces are when two or more forces act on an object at the same time. So we call it net forces because the forces combine together for a total force. A balanced force occurs when forces on an object are both equal in size and opposite in direction. So as you can see from the two gals there pushing the box, they are pushing with the same exact force, so the box isn't going anywhere because they are applying that same force from opposite sides. Likewise, even if you aren't pushing on anything or you don't think you're pushing on anything, you are always being pulled down by gravity onto the floor, and the floor is pushing up on you. So those forces are also balanced. How we get motion to occur is by unbalanced forces. So these forces combine to produce a net or total force that is not zero. So motion will occur in the direction of the larger force. So as the young lady and gentleman there are pushing the box, the young lady has more force than the gentleman, therefore the net force is going to be in the direction of the young man, with the remaining what is left after he has his force of pushing the opposite direction. So motion will occur when forces are unbalanced. So unbalanced objects are pushing with unequal forces in opposite directions. Velocity will only change if forces are unbalanced. The net force to move an object, when we combine those forces, you're going to take the difference between the larger and the smaller force. Again, when we, on the left there, we have the two working together, so they are combining their forces into a net force. And on the other picture, we have again that opposition. So the difference between the larger and smaller force is that motion in that direction. If we're going to talk about forces in motion, we're going to have to talk about friction. Friction is the force that opposes sliding motion or two surfaces in contact. Friction usually has kind of a bad rap. In some mechanical systems, friction can be considered a bad thing, but really it is friction that keeps you from slipping and falling when you walk across the floor. The forces between the soles of your shoe and the surface of the floor, whether it be contact or carpet or tile, you are going to have to overcome that friction in order to move. So what causes friction? The size of the force of friction depends on a couple of things. One, the materials involved, and two would be the type of surfaces involved. If you were to roll a ball, for example, across the floor on the right there, the nice shiny marble-looking floor, and on the concrete there in the image on the left, there will be a higher frictional force with the concrete because there is more nooks and crannies and rough surfaces to slow down that ball as it rolls. Whereas on the nice smooth tile, there is still friction, but the frictional force is much, much less. So frictional forces will increase when the force pushing the surfaces together increases. Okay, so here we have our skateboarder. So in order to move forward, the skateboarder is going to have to overcome two things. He's going to have to overcome the force of air resistance, which is friction due to motion through air, and the friction acting against the skateboard and the surface. So if that force is 100 newtons, which is our unit that we use for force, the skateboarder, in order to go forward, is going to have to push with 120 newtons of force to get motion in that direction. So different types of friction will occur on different surfaces. The most common type of friction that most people associate when they think of friction is what we call static friction. So this prevents two surfaces in contact from sliding past each other. In static friction, there will be no movement because there's no outside force that's acting on the object to cause it to move. So static friction is the friction between the two surfaces from sliding past each other. Sliding friction is also another type of common friction. This is going to act in the opposite direction to the motion of a surface sliding on another surface. So in this case here, we will have movement because the force acting on the object is greater than the frictional force. Once you overcome friction, motion can occur. Rolling friction is another type of friction. This is a frictional force that is reduced, not eliminated, and it slows an object down. So rolling friction is the least amount of frictional force that you would have to overcome. Wheels reduce that frictional force, reducing that contact from surface to surface. Another type of friction is going to occur when objects are moving through the air, whether they are moving forward through the air or falling down through it. Air resistance opposes the motion of objects that move through the air. So it causes objects to fall or travel at different accelerations and speeds. Air resistance depends on a few things. It depends on the size of the object, its shape, and its speed. For example, if you took a piece of paper, a flat sheet of paper, and dropped it from a height of 5 meters, that paper will slowly flutter down and eventually make its way to the surface. If you crumple that piece of paper up, it still has the same mass. You're not changing its mass. You're changing its volume, so you're making it into a smaller shape. The air resistance is going to be a lot less on the crumpled ball of paper, so it will fall through the air faster. If objects fall from a large enough height, eventually objects will fall while no longer accelerating. So as an object falls, the downward force of gravity, of course, since that is a universal force, causes the object to accelerate. So as the speed of the object increases, so does the upward force of air resistance. So the faster you travel through air, the larger the air resistance is on that object. And eventually, the upward air resistance will equal out to the downward force of gravity. So that object is still falling, but it's not falling any faster. It's not accelerating as it falls. So when air resistance and gravity are equal, that net force is 0. So the velocity of that object will not change. It will continue to fall, but it won't speed up or slow down as it's doing so. So terminal velocity is the highest velocity that any falling object will reach. So terminal velocity is when air resistance equals the downward force of gravity. This has been Physical Science 1, Chapter 3, Part 3 on motion, forces, and acceleration.